In this unit, we have been talking about quantitative values of a specific element or of a specific compound. So for example, if I know the number of molecules of a compound, we could calculate the number of moles, and from that we could find the number of grams. Or the reverse, if in a lab I was able to determine how many grams of a compound I have, I could convert to moles, and then I could convert to molecules if I wanted to. The interesting thing, though, is we've been only talking about one compound at a time or one atom at a time, and instead what we're going to start to do in this lesson is we are going to talk about converting between certain quantities within a reaction, so different compounds in one single reaction. So as always, I like to start with a real-world example, and so what I'm showing you right here is a recipe. This looks a lot like a chemical reaction with your reactants here and your products right here. So I'm going to write P for products, R for reactants. Now I'm going to show you one of these examples, and then I'm going to have you do a practice problem, and then we're going to move on and put it into chemistry terms. So in this problem it says, if I have 12 eggs, how many pancakes can I make? Well, if you look at the recipe, I know that to make 5 pancakes I need 1 cup of flour, 2 eggs, and a ½ teaspoon of baking powder. Now, please don't actually use this for your recipe. You need to add more stuff to make your pancakes more flavorful, but this is just an example. So, I start out with my given, which is 12 eggs. And I'm wanting to get into pancakes, so I'm going to do my dimensional analysis, crisscross swoosh. I'm going to put eggs on bottom and pancakes up top. Now, this relationship between eggs and pancakes is given in my recipe. I know that to make 5 pancakes, I need 2 eggs. And so when you do this math, what you should get is that with 12 eggs, I can make 30 pancakes. So if you notice, now all of a sudden, I'm not just converting between grams, moles, and molecules of one thing, so for example of eggs, even though this is a real-world example, I'm now being able to convert between numbers and quantities of one thing, so eggs, into another, so for example pancakes. So I would like you to do number 2 on your own, so please take a second right now and pause the video. Now we're going to put this into chemistry terms, and the first type of conversion we're going to do is just a mole to mole conversion. So we're going to convert from moles of one thing to moles of another. Now, if you look at the formula I gave you in this example problem, what you should notice right away is that I am not balanced. Okay, so I'm going to quickly balance us by putting a 2 in front of ammonia, a 3 in front of hydrogen, and now I'm balanced. All right. It asks how many moles of ammonia, which is NH3, are produced when 0.60 moles of nitrogen reacts with hydrogen. So what I'm concerned about right now is converting from moles of nitrogen into moles of hydrogen. So let's do that right now. My given is 0.60 moles of nitrogen, moles of N2. Okay. To convert between moles of one thing into moles of another thing, what I'm going to need to do is use the mole-to-mole ratio. Now that sounds intimidating, but all it is using the coefficients. So I'll show you how we do this. First, I'm going to put my units, which is what you always need to do. I'm in moles of N2, I want to get out of there, so moles of N2 on bottom. And I want to get into moles of NH3 up top. Now, whenever you have moles over moles, this relationship is just going to be the coefficients for these 2 molecules. So for NH3, there's a 2 in front, so I'm going to put a 2 here. So for every 2 moles of NH3, there are 1 mole of N2. All right, so you use your coefficients for your mole-to-mole ratio, and so 0.6 times 2, you will get 1.2 because you want 2 significant figures, so 2 moles, 1.2 moles of NH3. And yes, I would greatly appreciate it if you would include information like moles of NH3, because it does matter, because I started out with moles of N2 and now I'm getting into moles of NH3. So I want you to do just 1A. So pause the video right now and do that. In the last section, you guys learned how to convert from moles of one entity into moles of another. And so I'm going to represent that right here. So I have, let's say, moles of A, whatever A is, so moles of A. And I can convert between moles of A and moles of B. All I have to use is the mole-to-mole ratio, which is just the ratio of the coefficients. Okay? Now, if you look at this next problem, at this example, it asks you if 5.40 grams of hydrogen react, how many grams of NH3 are going to be produced. Now, all of a sudden, we're not converting just between moles to moles. We're now going from grams of one thing into grams of another. So there's going to be an added step. And the reason why is because I need to figure out if I start with a certain number of grams of A, I've got to go from grams, so in this case grams of hydrogen, to moles of hydrogen, then from moles of hydrogen to moles of whatever I'm trying to get into, which in this case is ammonia, and then into grams of ammonia, which would be grams of B. I can't directly go from grams of A to grams of B. The reason why, the only way to relate A and B is with this mole-to-mole ratio. So this is going to make very clear the fact that writing out your units, including the identity of what you're dealing with, is extremely important. So let's start with our given and get working on this. Now, a quick note, if it tells you it's reacting with an excess of nitrogen, all that means is that there is plenty of nitrogen and you can just ignore nitrogen. We're not concerned with it. We will in a later lesson, we will care, but for right now we don't. So our given in this problem is 5.40 grams of hydrogen, H2. Now my first step, I need to get into moles of hydrogen. So I'm going to crisscross swoosh. I'm going to put grams of hydrogen on bottom, and I'm going to put moles of hydrogen up top. Okay. I'm going to keep going. I'm now in moles of hydrogen, but I'm eventually going to want to get into moles and grams of NH3. So I'm going to convert into moles of NH3. So I've got to put my grams canceled here. I need to put moles of H2 on bottom. And I'm going to put I'm going to put moles, my bad, of NH3 up top. Because I know this relationship, this is just the molar mass. I know this relationship, it's just the mole-to-mole ratio, which I will put in a second. I've got one more conversion to go because I want to find the number of grams of NH3. So I'm going to crisscross swoosh again. I'm going to put moles of NH3 on bottom and grams of NH3 up top. All right, now I'm going to put in my values. So, just as a reminder, to go from grams to moles, I need to use my molar mass. As soon as you see grams over moles or moles over grams, automatically in your head you should be thinking that's molar mass. Now, the molar mass of H2 is 2 times 1.01, which is the molar mass of hydrogen. So it's going to be 2.02 is the molar mass of H2. That goes next to grams because the units for molar mass are grams per mole, and the number in front of moles is going to be 1. Now, for this mole-to-mole ratio, I need to use my coefficients, and what you should have realized is that I forgot to balance. So I'm going to quickly balance like we did before. All right. Now, the coefficient in front of NH3 is a 2, so I'll put a 2 here. The coefficient in front of H2 is a 3. Here, I now need to put the molar mass of NH3. That's why I put the H2 and the NH3 to make it clear what you're using. Now, the molar mass of NH3 is 17.04. A 1 in front of moles. So what I'm going to do now is take 5.40 divide by 2.02, multiply by 2, divide by 3, then multiply by 17.04, and what you will get is 30.4. If you round it to 3 sig figs, because this has 3 sig figs, my units are grams of NH3. Because what you should realize is that my grams of H2 cancel, grams of H2 cancel, moles of H2, moles of H2 cancel, moles of NH3 cancel, those cancel, and you're left with grams of NH3. And that is it, guys. I need you to complete number 1 again for the practice problem, and then you are done.